Hey guys, Mr. Backerberg here. In this video, we're going to look at finding square roots and comparing real numbers. So the first thing we're going to be talking about are square roots. But before we get to what square roots are, I want to quick remind ourselves of what it means to square something. So remember, if we have something like 3 squared, 3 being raised to the second power really means that we're taking 3 times 3. And 3 times 3 is going to give us 9. So we can say that 3 squared is 9. Now, when we're doing square roots, we're going to be working backwards. So we're going to be starting with a number like 9, and we're going to try to figure out what number multiplied by itself would give us that answer. So in this instance, when we're talking about 9, we would say that its square root is 3, because if we take 3 times 3, we get 9 as our answer. So the formal math definition of what a square root is, it says if b squared is equal to a, then we would say that b is a square root of a. Now typically we write out square roots as something that looks similar to this. This symbol over the top is called our radical symbol, and that just means that we're doing a square root. The number underneath that we're doing the square root of, that's called the radicand. Now all numbers technically have 2 square roots. One of them is positive and one of them is negative. The positive square root we call the principal square root. And the negative square root we just call a negative square root. So here we're going to look at evaluating some square roots. So this first one that we've got is the square root of 9. And this is what we just talked about. When we're looking at doing a square root, we're trying to think about what number times itself would give us the number underneath our radical. So we talked about 9. We said that 3 times 3 would equal 9, meaning that 3 is the square root of 9. Now notice there's nothing in front of this radical, so that implies that we want the positive answer. So we would say that the principal square root of 9 is 3. But if we look at this second one, we've got a negative in front, which means that we want to find the negative answer or the negative square root. So the answer that we get is going to be a negative number, and we want to think about what number times itself would give us 16. And the answer there is going to be 4. 4 times 4 is 16, so 4 is the square root of 16, but again, because we have this negative in front, we want the negative square root. Now this last one has a plus and a minus in front, which means that we want both answers. We want the principal root and we also want the negative root. Now we're looking at evaluating the square root of 25, so we're trying to think to ourselves what number times itself would give us 25. And the answer there is going to be 5. But since we want the principal root, the positive root, and the negative root with this plus and minus sign, I'm going to put a plus and a minus in front of this 5. So this means positive 5 and negative 5. Now those examples that we just did are all examples of what are called perfect squares. And a perfect square is a number that when you do its square root, you get a nice whole number answer with no decimals or fractions or anything like that. And there's a lot of perfect squares, but they're really spread out when you think about numbers in general. So I'm going to give you a chart of perfect squares to look at. And we've already looked at some of these. Like we looked at the square root of 9 being 3. And we looked at the square root of 16 being 4. And the square root of 25 is 5. But there's a whole list of perfect squares. This is only the list up to 20, but there's more perfect squares out there. But for example, when you start getting into larger numbers, it can be difficult to identify what the square root is. So if you're talking about something like 196, it's a perfect square. It shows up on this perfect square list, and its square root is 14. Or the square root of 361 is 19. But now not every number is going to be a perfect square, so eventually we're going to need other strategies as to how to deal with finding square roots of those values, but we're not going to worry about that right now. So we're going to do some more examples of evaluating square roots, and I want you to think about that perfect square chart as we're going through and doing this. So here we're doing the positive and negative square root of 81. 81 showed up on our perfect square list. Its square root is 9, but we want the positive and the negative root, so we have to remember to put the plus and the minus in front of that 9. Now the next one we're going to look at is the square root of 400. Now there's nothing written in front of there, so that implies that we want just the principal or just the positive square root. 400 was on our perfect square list. Its square root is 20. The next one we're going to take a look at is the negative square root of 289. Again, 289 was on our perfect square list. Its square root is 17, but because we have this negative in front, we want the negative answer. So the negative square root of 289 is negative 17. Now the last one we're going to look at is the square root of negative 100. Now if we think about our perfect square list, 100 itself is on the perfect square list, but we have to be a little bit careful because now the negative is underneath the radical. And when you're thinking about taking a number and multiplying it by itself to get a negative number, that's really not possible. So even though 100 itself shows up on the perfect square list, we're really talking about negative 100 here. And you can't do the square root of negative numbers. So we're going to say that this one does not exist. And the reason this does not exist is because you are not allowed to do square roots of negative numbers. Now one more example here with square roots. We're going to look at approximating the square root of 52 to the nearest whole number. Now 52 itself is not a perfect square. It doesn't show up on our perfect square list. But to approximate this to the nearest whole number, we want to think about some of those numbers that do show up on the perfect square list that are close to 52. One of those numbers that showed up on the perfect square list was 49, and the next perfect square after that was 64. So we're trying to see 52 is closer to which of these numbers, and 52 is closer to 49. Now if we think about these being perfect squares, when we square root these, the square root of 49 is 7, and the square root of 64 is 8. So because 52 is closer to 49 than it is to 64, then we can approximate its square root to be closer to 7 than it is to 8. So we would say that the square root of 52 is approximately or about 7. Now the next thing we're going to talk about, there's actually different kinds of numbers. And the first type of number that we're going to talk about are whole numbers. And whole numbers are numbers like 0, 1, 2, 3, so on and so forth. Okay, there's no fractions, there's no decimals, and this also doesn't include any negative numbers. But we can expand that a little bit further, and we get to these things called integers. So not only do we have 0, 1, 2, and going up from there, but we also have some negative numbers in here too. So negative 1, negative 2, negative 3, and going down from there. So again, there's no fractions and there's no decimals, but it has all of those whole numbers, those positive whole numbers, but it also has negative numbers as well. So we would say that the integers contain the whole numbers, the positive whole numbers, as well as their opposites, those negative numbers. The next set of numbers, or the next type of numbers, are called rational numbers. And a rational number is any number that can be represented or written as a fraction. So this includes the whole numbers and the integers, because we can take any whole number or any integer number and turn it into a fraction by putting it over 1. But this also includes repeating and also terminating decimals. It's possible to write those as fractions as well. Now, the opposite end of the spectrum from rational numbers would be irrational number. And an irrational number is a number that cannot be written or represented using a fraction. Now, collectively, all of these different groups of numbers together are called the real numbers. And if you think about a number line, a continuous number line, the real numbers make up every single number that's on a number line. So it includes whole numbers, it includes integers, it includes the rational numbers and the irrational numbers. All of those fall under the umbrella category of real numbers. But there is also something that's not real, and we call those imaginary numbers. And we don't talk about them specifically here, but later on in some of your higher level math classes, you'll dig a little bit deeper into imaginary numbers. But imaginary numbers come from doing square roots of negative numbers. Earlier on in this video, I said that you're not allowed to do square roots of negative numbers, but that wasn't entirely true. You can only do square roots of negative numbers if you're dealing with imaginary numbers. But like I said, that's going to come later on in some higher level math classes. So we're going to take a look at some numbers, and we're going to try to identify what type of numbers they are. And the first number we're going to look at is 5. And we're trying to decide, is 5 a whole number, an integer, a rational number, or an irrational number? And it could be more than one of these. Now 5 is a whole number. So remember, the whole number started at 0, and then we counted up from there. And there were no fractions and no decimals. Well, 5 doesn't have any fractions, and it doesn't have any decimals. So it is a whole number. The integers, remember, the integers included the whole numbers, but it also included their opposites or their negatives. So since the integers include the whole numbers, then 5 is also an integer. Rational numbers were numbers that could be written as fractions, and we could take 5 and turn it into a fraction by putting it over 1. So 5 is a rational number. Now, an irrational number is a number that cannot be written as a fraction. And since 5 can be written as a fraction, then it is not irrational. So I'm going to put an X in this box. It's not irrational. The next number we want to take a look at is 0.6. Now, whole numbers, we said there was no fractions and no decimals. And 0.6 is a decimal, so it's not a whole number. Integers were the whole numbers and their opposites. And since 0.6 is not a whole number, then it also can't be an integer. Now, as far as being a rational number, we have to try to think to ourselves, can we take this decimal and write it as a fraction? And one of the things that I mentioned was that rational numbers have terminating decimals, which means that they stop. And this decimal has stopped. Now, this first place after the decimal point is the tenths place. So because this is 6 tenths, we could write that as 6 over 10. That's the same as 0.6. So 0.6 or 6 tenths is a rational number, which makes it not irrational. Now, as we're taking a look at this one, we've got -2 and 2/3. It's not a whole number because we've got that fractional piece. And since it's not a whole number, it's also not an integer. It is a rational number. There's a way that we could write this as one big fraction. So it is rational. And since it is rational, then it cannot be irrational. Next one we've got here is -24. Whole numbers started at 0 and counted up from there. Whole numbers did not include negative numbers, so it's not a whole number. Integers included all of those positive whole numbers and their opposites or their negatives. So the integers do include negative numbers. So -24 is an integer. -24 can be written as a fraction by putting it over 1, so it is rational. And because it is rational, that means that it is not irrational. And then the last one we've got here is the square root of 8. Now, 8 did not show up on our perfect square list. So when we do its square root, we're not going to get a nice whole number answer. So this one is not a whole number. And since it's not a whole number, it's also not an integer. With square roots that don't work out nicely with things that are not perfect squares, they're also not rational, meaning that there's no way for us to write them as a fraction. But when you have a square root of a number that's not a perfect square, it will always be an irrational number. So the square root of 8 is irrational. That's going to be it for this video. Thanks for watching.